Okay, cool. Hi, everybody. I'm Aaron. I'm a engineer at Blockstack. I work on really all sorts of stuff there. So that's me. I'm going to talk a little bit about building, how people build decentralized apps. Let's hide this. That's not going to be useful. No, minimize. Yeah, there we are. Okay, cool. I'm going to talk about a little bit about how you actually go about building an app on Blockstack, why you would want to build an app on Blockstack, and sort of a little bit about like the architecture sort of underpinning the library and platform that we provide that allows people to create the sort of awesome apps that Justin has created. Cool. So first off, you might be wondering, like, what is Blockstack? And I guess it's a lot of things to a lot of people, but the answer that I have is that it's a platform for building decentralized applications where users are able to choose where their data is stored, not the application. So someone asked a question earlier, like ultimately, if users choose to store their data in like GCP or S3, like how's that any better than like the world that we currently live in? I think that like my answer there is that the relationship that someone has when they pay for storage on GCP is like very different than the relationship that they have like today with Twitter, right? Like when I tweet, Twitter is doing pretty much whatever it wants, whenever it wants with my data, right? Which is very different than like when I open a GCP account. So so that's what Blockstack is. So maybe one of the first questions a lot of people will ask is like, why do I want to make a decentralized app? Like, why do users want to use decentralized apps? Why is decentralization important? And I think the answer there is that the web that we have today is highly centralized. Like the applications everybody's using are like very centralized. And when we look at like what that ecosystem has become, I would say that the apps that we use today, they're hoarding way too much of our data. They're using that data in totally inscrutable ways. And the way that I think about that is like, if I post a photo on Instagram, right, and I like say, I only want to share it with my friends, I have to sort of like implicitly trust that like Facebook or whoever they sell Instagram to at some point in the future is like responsibly only using that photo to share it with my friends, right? They're not using it in say like their media or like publicity about Instagram, which of course they do, right? Like you have signed away that right unknowingly as a user of Instagram or any other application. So they're using their data in ways that like you can't scrutinize and you have no way of scrutinizing. And finally, these applications have like, at this point, a pretty long history of not treating this responsibility over our data with the kind of respect that it deserves, right? Like if you look at the sort of data leaks that we have today, they're really like astonishing, right? Like you can pick a random month of the year in the last like 4 years and find data leaks of 100 million users' data at a time, which is mind-blowing. Like if you told somebody in the 90s that it would be a regular occurrence that 100 million people's information would be exposed to the world, I think that they wouldn't believe you. So that's kind of the world we live in. And decentralization as an answer is saying like, hey, what we're going to try to do is we're going to try to like take this data away from these applications and give it back to the user, put it back in their control. No slide. That's fine. Oh, it's over there. Not that much is happening on the following slide. So I'll just like sort of walk you through it and wave my hands dramatically as if there was a slide. So in this talk, basically what I'm going to go over is like how Blockstack's decentralized platform works and like a sort of a mile-high view. But if you like really boil down into the details, it's not that complex. I don't think you need a computer science degree to figure it out. And then after that sort of brief overview, I'm going to give you maybe a bigger pitch of why you should be using Blockstack. And then I'll like sort of run through a couple of examples of how you can build web apps that use decentralized authentication and decentralized storage using our JavaScript library, Blockstack.js. And hopefully you'll see how like simple it can be. Okay, so the way that I like to think about the Blockstack architecture is that we're trying to solve one problem, and we have to do it through a number of steps. So we want to provide Blockstack.js, which is basically an application library for decentralized applications to use that allows them to interact with storage in ways that are like familiar to them, that would be, you know, not much more difficult than like interacting with local storage in a browser. With the like small caveat that instead of the application developer choosing where data ends up, the user of the application has chosen, and the library sort of sorts it out. Okay, so that's the top level of the Blockstack architecture is the libraries. The first problem that you need to solve if users are choosing where their data is going is that you need a uniform way to interact with these like possibly heterogeneous data systems, right? If a user chooses to write data to their local disk versus Google Cloud or S3, like all of those interfaces are like very, very different. And so if you want to provide a uniform way for application developers to program against this, you need some sort of protocol or you need some sort of software there. And so for that, we have a system that we call Gaia. Okay, so once you've provided this, like everything seems like it should be solved, right? Like you have a way to write data to where the user says they want their data. But then you realize that there's actually another problem here. So if you want to make an application where you're actually sharing data between users, like let's say you have two users, Alice and Bob, and they want to like share a document from one person to the other. In a centralized application architecture, like this is not a hard problem, right? Alice is communicating with some application server in California, and Bob is communicating to the same server. So if they want to share a document between each other, they just write that document to that server, and that server knows how to sort of apportion access control. That's not true of the system that we've created. And so what you need is like a system for routing. And when you think about routing as a problem, really what it is a naming problem. So like routing on the internet today is done by DNS, the domain name system. So ultimately what we needed to provide this support for this was the Blockstack naming system, which was a system for sort of mapping unique names like user IDs to locations of Gaia servers where people know or the application can know how to read data from. And in addition, because we want to use cryptography to make sure that all of these communications are secure and trusted, we'll also use this naming system to sort of bootstrap trust in public keys. Okay, so that's sort of the multi-tiered architecture at a very high level. We then blow this up a little bit because implementing these components actually requires a bit of effort. So at the top level, we have the Blockstack.js library, which is soon to be TypeScript library that's open source. You can find it on GitHub. And it's interacting with these other components in a pretty straightforward way. We also have the Blockstack browser, which is pretty much how users onboard into this system, right? If you have a decentralized system where users have to like manage names and keys and things like that before they can sign into different applications, connect to different storage providers. Like you need some sort of user-facing software that helps them manage that and that has access to their sort of root private keys. So that's the Blockstack browser. It's also open source. You can find it on GitHub. For Gaia, we have an implementation of the Gaia protocol, which is just a Gaia hub server. It's also now implemented in TypeScript. You can check it out. It's pretty straightforward. Basically, all it's doing is implementing a uniform API for storage with different sort of pluggable backends. So you can plug in S3, Google Cloud. You can just back it with a local disk, things like that. And that's all fairly straightforward. Where things start to get kind of complex is the naming system. Because the fundamental thing that we're trying to achieve in this naming system is that there's no central authority that's deciding who owns a particular name. Like if you're wondering like what public key is associated with Alice, you have to have like an untrusted way of figuring that information out. And like who controls names, who's able to like map a given name to a given location. The way that we solve this problem of coming up with like a decentralized way to resolve names is that we have a blockchain for doing this. So blockchains are really good at resolving who owns what thing. And so it works pretty well for implementing a naming system. So there's three components interacting in the Blockstack naming system. We have at the total bottom level, we have a blockchain that's basically just encoding Blockstack naming system operations. So these are things like user registrations, which can be done without any sort of trusted party. Users can just register a name themselves. Things like name transfers, name updates, stuff of that nature. That's what the blockchain is encoding. And then we have a server program called Blockstack Core, which is reading information out of the blockchain and building up a database of basically all of the names that have been registered and what public keys and Gaia locations they map to. These Blockstack core nodes communicate with each other through like a peering protocol called Atlas. They're exchanging larger information than what you could store efficiently on a blockchain. So that's where you actually get URLs mapped to different usernames, things like that. But ultimately, all these Blockstack core nodes are trying to do is provide an API for these higher level pieces of the stack. So what does this API look like? Like, what does a Blockstack core node give you? So if you queried a Blockstack core node, so like here we have a public fleet that we run, where you can just query it for information about names that people have registered or just exist in the system. If you ask it for information about a name like Aaron.id, which is mine, it will tell you a variety of information, just replies with JSON object. Pretty straightforward. It's got an address, which if you've ever interacted with Bitcoin will look pretty familiar to you. That address is essentially a public key. It's actually a hash of a public key, but you can kind of prove statements from somebody that has that address, similarly to how you interact with a public key. You'll find information like the DID, which is like a standardized way to do decentralized identifiers. There's like a decentralized identity foundation, which if you're really into like standards is publishes a lot of documents that are fascinating to read. And then there's a zone file. So this format will look familiar to you if you've ever looked at a DNS zone file. And if you haven't, I guess it won't, but it's pretty straightforward. There's basically just a URL here, which Blockstack.js uses to figure out where all my Gaia data is stored. And that's just a regular HTTP URL, like it's resolvable anywhere you can resolve URLs. Okay, and then when you're, from a user's perspective, when you're sort of onboarding into the system, that's when you're presented with your choice of like where your data is going to be stored. And the way that this works is, you know, you go into an application, like let's say you're trying to sign into Graphite. You click sign in with Blockstack. If you've never used Blockstack before, you get like routed to a public facing website that implements the browser. That, you know, it onboards you, it gives you, you fill out some stuff and you get like a username. And then you get prompted with a choice of where you want your data to be stored. So you can choose to use a Gaia server that Blockstack PBC runs, which is at gaia.blockstack.org. So that's the one I was using on aaron.id. Or you can sort of select use a different provider and you punch in the URL there and it gets all sorted. And that's really sort of the last time that you really have to think that much about like where your data is going to end up. Every time you onboard to an application or every time you sign into an application after that, that application just like automatically knows to use your Gaia storage provider, the one that you selected. Okay, so why would you want to build on Blockstack? So there's two sort of sets of benefits. So there's benefits for developers, and there's benefits for the users of the applications. And they're kind of different audiences. So I think for developers, like one of the, I think, first things that is really great is that you don't have to host everyone's data. So if you publish an app, like it can basically just be a fully client-side app. You don't have to host a giant server that's, you know, running a database and hosting all of your users' data. Your users won't have to deal with passwords. You don't have to deal with figuring out how to store them. And, you know, this all can sort of reduce your server costs because more and more of the logic of your application is actually getting pushed to clients. Benefits to users, I sort of already talked about earlier when I talked about decentralization in general, but basically like you as the user, you get to own your data in a way that you don't in applications today. Like you're controlling where it's stored. You can control who has access to that data. If you set up your Gaia server on your local disk, like you can very clearly see what data the application is sort of creating about you, what data could possibly be shared, and you can sort of edit that, remove it, delete it whenever you want. Okay, so how do you actually build an app on Blockstack? Like what is that going to look like in some sense? So a Blockstack app is basically interacting with the Blockstack API to access a couple different things. So you're going to have like authentication and you're going to have to deal with storage. So the basic questions are like, what does integrating Blockstack Auth into my app look like? How is the Blockstack browser going to work? Because that's going to affect your user's onboarding experience. And then once you figured those things out, you need to figure out how Blockstack storage will integrate to your app. So I'm going to cover those three topics. So it's really pretty easy to get started building a Blockstack app. We have a Yeoman generator. I think that's how you pronounce that, Yeoman, whatever. That's pretty straightforward. You just type yo Blockstack. It's great, great CLI command name. And then run npm run start, and like you'll have an app that uses Blockstack. It's kind of just a hello world app, but you'll have like all the code sort of in place. You'll have some structure there. And that, for the most part, works almost every time. If it doesn't, that GitHub repo is where issues can be filed or pull requests open. You can also just install the Blockstack.js lib into your into your app directly, just npm install Blockstack. The modules are pretty heavy, so it will take a while, unfortunately. Cool. So once you've got the library set up, basically what you're going to want to do is like throw a sign-in button on there. Implementing sign-in is pretty straightforward if you don't want to do anything too fancy. If you're okay with us controlling your sign-in flow, basically all you need to do is call blockstack.redirect to sign-in. At that point, like the Blockstack library will sort of kick in and do everything needed to initiate the sign-in flow. You might want to include some additional parameters there. So like if you want to redirect to a specific URL, once they've gone through sign-in, you can add that parameter in. If you're storing your app manifest in an unusual location, or you're looking for a different set of permissions than the default set of permissions, then you request them there. Okay, so what happens when you call redirect to sign in is Blockstack.js will detect whether or not the user has like a local version of the Blockstack browser installed. If it detects that the user does not have a local version installed, it will redirect to the hosted version of the browser, which is just browser.blockstack.org. If the user has sort of already created an ID before, so they already have a Blockstack username, at this point they'll be presented with an authentication dialog where they select like which ID they want to log in with, and they see things like what origin your app is coming from, the permissions that it's requesting, an app name, a cute logo. So like here, we have like carrot. Wonder what app this is going to be. I don't know. But yeah, you get presented with that kind of stuff, and you just click through as a user, approving or denying the request, and then sign in. So it kicks through. Yeah, so like I said, by default, you end up at browser.blockstack.org. But users can sort of optionally download and run a local version, in which case they'd get redirected to something running on localhost. All right, so once the authentication is returned back to your application, oh, no, this is manifest. Okay, so when you're building an app and doing the sign-in process, all of that information, like the app name, that little logo that we saw, and the URL that the application is supposed to land on once they've finished the redirect process, all that is stored in a manifest file on your origin. The manifest file must be on the same origin as the app requesting the authentication. That's like a security precaution so that somebody couldn't like hijack your authentication request, and try to steal like app-specific data, things like that. But these manifest files are pretty simple to create. The sort of big gotcha when you're deploying your first app is that the manifest file needs a very permissive CORS setting, because browser.blockstack.org is going to be requesting this file. So you've got to allow that origin. Otherwise, your users will all get errors when they try to sign in. But whatever. Okay, so let's say the auth flow is completed successfully. In your app, you have a call that's like, is sign-in pending? So that just checks whether or not you're accepting a redirect. So you're accepting like the last phase of the sign-in loop. At which point you just call handle pending sign-in, which initializes the Blockstack library's like user session and stuff like that. And then you can begin interacting with the user session. You can check whether or not a user session is like currently active by calling is user signed in, at which point you can start interacting with the session, like loading user data, stuff like that. So what kind of data do you get immediately upon accepting a sign-in? Well, you'll get a profile. So each user can create like a public profile, and that'll be shared across any app. So when you first log in, you can get things like user's avatar, simple description, name, stuff like that. You'll get the email. You'll get that information that we saw earlier available from core nodes, which is like the decentralized identifier and the identity address. Now we get something new here called the app private key. So the app private key, as sort of said before, is a specific point on a SecP256K1 ECDSA curve, which is not an exciting fact. But what is exciting is that like you as an app developer just got a private key that is unique to your user and unique to your application, and will be the same every time they sign in. And the user doesn't need to manage it separately from managing their like sort of global identity. So the user manages like this single identity, and they're able to log into any number of apps, and all of those apps get a unique private key that they can use for authenticating rights, like signing data, encrypting that data and sharing it with just specific sets of people or just your friend, things of that nature. So this is pretty powerful if you want to build an application that involves any amount of cryptography. Okay. Once you have a user session, in addition to having that app private key, you now have access to an app-specific like bucket in the user's storage. So if you call blockstack.putFile, you give it a file name and some data. So interacting with it is kind of like interacting with a key value store, like you have putFile and getFile. If you give it this file name, basically what you're doing is you're writing this file to an app-specific bucket on that user's data storage. And otherwise, like all of the processes underpinning that are like kind of invisible to the application itself. Like you don't need to worry about looking up where that user's Gaia Storage is. The library sort of takes care of all of those steps for you. Yeah. Uh-huh. So, how do you get to authentication? Right, yeah, so I guess I did skip over this. So right up here at the top, you have username, mat.id, which is the logged in user's like owned name. And the library does this automatically when it accepts a sign-in request, where what it does is it queries a Blockstack core node for the public key associated with mat.id, and it confirms that the sign-in payload that it received was signed by that same public key. So this happens like under the hood in Blockstack.js, but like if you were really enterprising about it, like you could also confirm this at the application layer, right? Like let's say you had some Blockstack core node of your own that you wanted to query sort of separately, or your own like public keys that you wanted to reconcile this with. You could sort of confirm all that on your own using. Yeah. Cool. Yeah, and so once you've like put data to a particular file and you want to read back data, like all you have to do is call getFile. And you get back this message, hello. Yeah. Okay, so putFile and getFile by default only accept basically the file name and some data as options. And by default, they encrypt and sign all of the data with the user's app private key. But if you would like to change that, there's like additional options that you could supply to put file and get file. So like, let's say you wanted to implement something like group encryption where you're participating in a group. You could pass a public key that you want to encrypt with or what have you. Yeah. Do you have a question?
Yeah. Usually when I create an ID in Blockstack,
Yep.
it creates a public key and stores it in the blockchain.
Correct.
But it also creates a private key and stores it locally.
Yes. Yeah.
Okay. And how does it use that, while Blockstain not? It has to use the
Yes.
public key, right? I mean, there is no mention of how we are going to access it.
Yeah. So when you sign up for Blockstack and you sign up for a username, you sort of initialize your public key. That is done using like client-side encryption in your browser. You get a like 12-word phrase that encodes your private key. You should write that down. You're instructed to write that down. And so then at that point, that's you have control of your private key. It's also stored encrypted in browser local storage so that when you want to sign in to an app later on, you don't have to type in your private key.
So it automatically
Yeah.
does it behind the scenes.
Behind the scenes, yeah. And it uses local storage, so it doesn't ever leave your browser. Though, yeah, I mean, local storage isn't a perfect place to be storing private keys ultimately. Like there's probably a sensitivity limit, I would say, for like what you should be doing with the private key, as long as it's in local storage. Yeah. Yes. So if you want to use, so the question was, how do you do this across platforms if it's stored in local storage? The answer today is that you basically restore from your 12-word phrase on your mobile device, something like that. So you have to sort of manually input your private key. Yeah. Yeah. So as an app developer, right, like if you do a get file, it could return a 404 because the user has chosen to delete it. Like, yeah. Yeah, I mean, there's not an easy way to do that. I mean, you need to check. Like it's a slightly more hostile, say it's definitely a more hostile programming environment than just a storage system that you as the application developer control, right? Because ultimately, like if the user turns off their computer and they're storing it on local disk, right? Like you can't access the files at that point, right? So yeah, you have to do a lot of defensive programming in this world. Yeah.
Yeah, so if you're opening a storage room and storing it in local storage, how do you prevent cross-sites?
Well, the private keys are stored in the browser, which does not have as permissive of CORS rule, right? Like it's important that the app's manifest file has permissive CORS, right? Yeah, not like, yeah, the app itself shouldn't be exposing all of its endpoints. Yeah. Yes, so various amounts of various private keys in the system are encrypted at sort of various times. And I'd say in general, private keys should get encrypted. But it's also why you want to use multiple private keys. So like in our system, we have like a root private key that's then used to derive other private keys. And what this lets you do is say like, okay, well, we're going to encrypt the like master private keys. But some of these child private keys we're not going to. And so you can kind of control, which information has like sort of which levels of sensitivity, if that makes sense. Cool. All right, so that was the storage interface. Let's see. Okay, so okay, that's like great for just like getting a file and or putting a file and retrieving a file when you're interacting within a single user session. But like, let's say you wanted to build an app where users were able to share data with each other, right? So we call this like multiplayer storage, but I guess like in traditional application programming, you just call it storage, but whatever. So we have this name, multiplayer storage, sharing files. So an application that's going to do this needs to request a new permission from their users, which is the publish data permission. When an app presents the publish data permission to a user, and the user approves and goes through the sign-in flow, what happens behind the scenes is the Blockstack browser has to write the URL for the like app-specific storage location to the user's profile. And the reason that it has to do this is because every single app is using a unique storage bucket that's like impossible to derive from other app storage buckets, right? Like these entries are in some sense independent of each other. And the reason that you need to know where user data is getting stored is because if like I as a user, Alice, want to look up some file stored by user Bob, I need to know sort of like the root location that Bob is storing his application data so that I can get started reading data from Bob's Gaia Storage. Okay, so if you're trying to share files, the default options in put file encrypt with the user's own public key, which means it won't be readable by anyone else unless you like shared that private key with them, which would be a bad application programming pattern. So the sort of quickest way to share data directly between users without doing like a key lookup, implementing a key lookup system, which you can do. It's not that hard. But the quickest way to get it done is first to turn encryption off so the other user can read that data sort of directly. So here, you're just uploading status.txt, which is just some publicly accessible information. And then on the other hand, what the application does is when it calls getFile, it supplies the username of the user that you're trying to get the file from. So it's exactly the same as sort of the single player getFile, putFile, but now you're adding another username into the mix so that you're reading Matt's status.txt instead of your own. So that's all cool. What does this look like from like a user's perspective? So if I as a user had set up like my Gaia storage system to be running on like DigitalOcean, DigitalOcean actually has like a really nice file browser interface if you've ever used it. It's kind of cool. So if you were using DigitalOcean as your backend and you're interacting with some app, you can go in to your DigitalOcean account and see all of the data being written by your app. And you could copy that data out, delete it, edit it, and the app at that point can't do anything about it. So it's pretty cool. It's kind of fun to interact with an application and go in and see the actual data that it's actually been interacting with. Yeah, so that's pretty much it. If you're excited about building an app on Blockstack, which I think you should be, we have a tutorial called Zero to dApp, which is pretty cool. It should only take about an hour, and you can get a free t-shirt with pretty cool logo on it. And it'll teach you a lot about how to make a dApp. If you're interested in asking other questions, you can join our Slack. We have a forum. You should check out App Mining, which is a pretty cool program to sort of incentivize people to build apps on top of Blockstack. All of our code is open source. It's on GitHub. You should check it out. If you find bugs, let us know. We have a white paper that describes sort of our original architecture, and yeah, other meetups you can find. Yeah, and I can take questions.
Yep, any questions?
Is there a method for users to move their data from one provider to another?
So there's an API call on the Gaia server called list files, which just like outputs all of the files that an application has written to your bucket. That paired with the API for reading data, you have an ability to migrate. We have a CLI tool that kind of like does that. But it's not like we don't have like a very user-friendly way to do it, but we would love to. And it would be a great place for someone to contribute. Yeah. Multiple backend, like multiple storage providers. Yeah, so, right. So right now there's not like a easily pluggable way to do that. I mean, you could sort of set up an ad hoc system because you do have like local disk as a backing option. That would require a lot of work on basically your part to like back your local disk with these various providers, which is possible. But that's like something that I think that we would like to see in the future is the ability to sort of compose backends. Yeah, I think it's something like that.
Sounds like an interesting open source project or even service to offer to other app developers. And then you have a thing that can plug into any app.
Yeah. Yeah. I mean, you don't. I mean, that's the name of the game, right? Right. So the system as it exists today is every single one of the like Blockstack naming operations is actually has like one-to-one correspondence with a Bitcoin transaction. Like there is a Bitcoin transaction that is encoding my name registration. And the Blockstack core node is reading that history of basically Bitcoin transactions, filtering out the Blockstack related ones and building up a chain history that way. And so like the chain that exists today, you would need to 51% attack Bitcoin. But I think we have plans in the future to sort of fork away from that current dependence on Bitcoin, in which case we will need to start worrying about basically an independent mining. Who pays for what? Well, if you are a user and you want to register your own name directly, you've got to pay. However, we have like a multi-layer naming system where we have namespaces, names, and like subdomains or namespaces, domains, and subdomains, where like the domain is registered directly onto the blockchain, and subdomains are registered by domains on behalf of other keys, but they're like batched into transactions. So if you go to browser.blockstack.org, you get like a free name, which is a subdomain. And that subdomain is included in like a batch of registrations. And all of those batches are basically like one Bitcoin operation. That Bitcoin operation is currently subsidized by Blockstack, but it's pretty cheap because we can batch like 100 names in a single Bitcoin transaction.
I want to piggyback on that because there's a cool enterprise application that this whole namespace concept, where if you're selling to businesses that want their users to log in with like Joe.acme company, right, as their username instead of Blockstack, you can help spin that up for the company, spin up the namespace, and they would just be taking care of the actions. Charge that upfront if you want to, but it's sort of like a white, it enables a white label service.
Yeah. Yep.
Since users can choose to go much further on data, like it's like your page that like I'm using this not until or this not well, I don't want to
Yes.
pay for storage.
Right.
Is that blog also use your application?
Yeah. So today we have like a default hub that we provide users that join the system, but I think it's still kind of an open problem of like how this is going to look in an ecosystem where you want users to be paying for their own data, but like I think that's kind of like it's a hard sell often because like users have gotten used to not paying for data. So right.
As a user who doesn't want to pay for data, is that possible with a decentralized app?
Right. I think ultimately somebody's got to pay for data. Ultimately, you've got to look at the incentives at play, right? If you look at like how Facebook works today, right? Like Facebook is paying for users' data, right? Like they're paying for the storage. What Facebook gets from that is, I guess the most powerful propaganda platform that's maybe ever existed. That's pretty powerful as a concept. That's nice, but like I think like in a world where users have to pay for their own data, I think there's probably other models out there. I think it's just kind of an open question.
I think as an application developer, if you're making the decision that you want to give somebody then you would do it, right? So is it possible to yes,
Amazon code to like ask for it.
Oh,
so,
yeah.
Yeah, so when you set up, I think Aaron showed a slide with the choose, or it's choose your own storage provider or select Blockstack. There is, I don't know if this is the version, you can change that so the app developer can supply.
Yeah. Yeah, so an app developer could supply like a recommended storage, something like that. Yes. Yeah. Yep.
You're using Blockstack.js. Why couldn't the user use Chrome browser with the same items?
Oh, well, yeah. So I guess the name Blockstack browser is a little, can be a little confusing. It's actually like it's a web page, basically. Like it's running, like on my computer, it runs inside of Chromium. Like it's a browser for Blockstack apps, but it is not a wholly independent browser. Yeah, it's more like an authenticator in its current form. Yeah. Yep.
When you say you're incentivized browsers, is that in some kind of
It's currently in Bitcoin. Yep.
There is an API called like put file. Do you also have like maybe like scope files where you just upload an entire file?
Yeah. So put file, you're basically uploading the entire file. Yeah. 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 It's basically store file. Sure. Yeah.
How can one use your token? You have your own token, right?
Yes. So there's a Stacks token. So you can use it to register names today, or you can transfer it between addresses. Or namespaces. Yeah.
Okay,
Yep.
one more question.
Oh. People have built Blockstack apps in any number of different like front end, using any number of different front end libraries. So
Like you wouldn't use the server at all, or like would you have a node server Blockstack and you could hash to?
in an ideal world, you don't have a server at all. Yeah.
But you may have like a homogeneous solution where you have a front end app and it interacts with Blockstack, but maybe you have some proprietary thing that you run on your server as well.
Yeah. Exactly.
Cool. All right, let's give him a round of applause.
Thanks.